Hello students, now we are going to see the next part from the real number chapter, that is the fundamental theorem of arithmetic. Now what is this fundamental theorem of arithmetic? The statement is also given in the textbook that every composite number can be expressed or factorized as a product of primes and this factorization is unique apart from the order in which the prime factors occurs. The fundamental theorem helps us to find the HCF and LCM. This method is also called as prime factorization method. For example, suppose the number is 140 and the question is express each number as a product of its prime factors. So you can find the prime factors of this 140 as 140. This method is there for you from the 7th standard. Five sevens and 7 ones. So like this we can find the prime factors of 140. These prime factors also we can find by tree diagram, like 140 is here and divides like 2 and 70. This 70 again we can find the factors of this as 2, 35. This 35 also again we can factorize as 5 and 7. Okay, so you can find the prime factors by this method or by this method. This you have studied. And these prime factors we can write like 140 is equal to 2 into 2 into 5 into 7. Okay, 2 is there 2 times, so this can be written like 2 square into 5 into 7. I will move to the next question. Prime factors of 156. So 156 prime factors we can find 156, that is it can be go by 2 divisibility test we are knowing, and we can use the divisibility test here. 278, again it will go by 2. Here it is a 39, again it can go by 3 here, so it is 3, 13. So we got the factors here 2, 2, 3 and 13. So here 156 we can write as 2 into 2 into 3 into 13. 2 is there 2 times, so 2 square into 3 into 13. Okay. We can take another example. For example, 3825. 3825. This 3825, it can go by 3. By divisibility test, if you see 5 plus 2, 7, 8, 7 plus 8, 15 plus 3, 18. So it will go by 3. And the remainder will be here 1, 2, 7, 5. Now this also we can factorize. This is here 3. By 3 it will go 12 plus 2, 14 plus 1, 15, 1 plus 5, 6. So by 3 it will go, it is 4, 2, 5. Again, as the last digit is here 5, so it will go by 5. It is here 85. By 5 again it will go 17 5s are 85. So you can write this 3825 as 3 into 3 into 5 into 5 into 17, and you can write this as 3 square into 5 square into 17. Okay. So like this we can find the prime factors of the given number. Two more examples are there in the textbook. That is prime factors of 5005. 5005. This you can write as, by 5 it will go 51001. This again by 101 will go by 7, and it will be 7 and 7 143. This 143 by 11 and 13. So we can write 5005 is equal to 5 into 7 into 11 into 13. One more example is given, that is of 7429. 7429. Now this 7429 is going by 17, and if we divide this by 17 we will get 437. Again this 437 will go by 19 and remaining 23. So this 7429 factors we can write as 17, 19 and 23. Okay, so like this we can find the product of its prime factors. Now if we get the product of the prime factors, then it is easy to find the HCF and LCM. For HCF and LCM, we know that HCF is product of smallest power of each common prime factor prime factor, common prime factor in the numbers, and LCM is product of the greatest power, of each prime factor, in the numbers. This you have studied in your earlier classes, that HCF is nothing but the product of smallest power of each common prime factor in the given numbers, and LCM is product of greatest power of each prime factor in the numbers. So here we are now going to find the HCF and LCM of any two positive integers. So first we will take an example of find the HCF and LCM. Find HCF and LCM. Find HCF and LCM of 60 and 72 by prime factorization method or using fundamental theorem of arithmetic. Prime factorization method. Like this question can come for 2 marks in the board exam. Find the HCF and LCM of given numbers by using prime factorization method, or also it will be as by using fundamental theorem of arithmetic. Like this question will come. So prime factors of 60 we can find as 2 into 3 into 5, that is 2 is here 2 times, 3 into 5. Prime factors of 72, 2 into 2 into 2 into 3 into 3, that is 2 is here 3 times and 3 is here 2 times, so that we can write HCF of 60 and 72 as HCF is nothing but product of its smallest power. आता स्मॉलेस्ट पॉवर इथं 2 क्यूब आहे, इथं 2 स्क्वेअर आहे. स्मॉलेस्ट पॉवर काय झालं? द स्मॉलेस्ट पॉवर इज हिअर 2 square will be the smallest power. Here 2 cube is here, 2 square is there. So smallest will be 2 square, na? Here 3 square is there, here 3 is there. So 3 raised to 1, the smallest power of this common factor is what? That is 3 raised to 1. So 3 raised to 1. 5 is there in 60, but 5 is not there in 72. So that will not take. It is about the common factor. So we will take 2 square and 3 raised to 1. That is the smallest power of each common prime factor. So this is here 4 into 3, that is equal to 12. So Here HCF of 60 and 72 is 12. LCM of 60 and 72 is equal to LCM, we have to remove. So what is LCM? It is the product of greatest power of each greatest power. Here 2 square is there, here 2 cube is there. So greatest power will be what? 2 cube. ठीक है. Here 3 raised to 1 is there, 3 square is there. So greatest power will be what? 3 square. LCM is a product of greatest power of each prime factor. Common is not written. It is a each prime factor. So we will take 5 also. That is a 5 raised to 1. 5 raised to 1 only one term is there. So 5 also we will take. So 2 cube into 3 square into 5 raised to 1. If we find the product, that is a 360. So like this we can find the HCF and LCM of given two numbers. Now one more example we will take here. Find the HCF and LCM of 510. Find HCF and LCM of 510 and 92 is the question. So first we will find the prime factors of 510. 510 by 2 it will go. So 2 2s are 2 5s are 2 5s are. Then by 5 it will go. 5 5s are 5 1s are. By 3 it will go. 3 1s are 3 7s are and 17 1s are. Same way 92's prime factors we can remove. That is 2 2 4s are 2 6s are 2 23 23 1s are 23. Okay, so you can write now 510 as a product of its prime. So 510 will be 2 into 5 into 3 into 17. ठीक है. And 92 you can write as 2 into 2 into 23. ठीक है. Now we have to write the HCF. So HCF of both these numbers will be what? This 2 into 2 into 23, that you can write as a 2 square into 23. HCF is a product of its smallest power of each common factor. So here 2 raised to 1 is there and here 2 square is there. So we will take 2 raised to 1 because it is the smallest here, 2 raised to 1. Again, is there any common factor? No. So there is no common factor between 510 and 92. So HCF of the number will be 2. Now we will write the LCM. LCM is the product of greatest power of each prime factor. So here 2 raised to 1 is there, here 2 square is there. So greatest means we will take 2 square into, here 5 is there. So each prime factor it is said. So 5 also we will take, 5 raised to 1. 3 is alone here, 3 also we will take, 17 also we will take. And here 23 is also there, so 23 is also we will take. And the product of this will be the LCM. And so here the LCM is, if we multiply these all, we will get the LCM as 23460. The product of this is coming 23460. So like this we can find the HCF and LCM of given two numbers. There is one relation between HCF, LCM and given two numbers, that for any two positive integers A and B, HCF of A and B is equal into LCM of A, B is always equal to product of the given number A into B. So HCF of two numbers A and B into LCM of two numbers A and B is always equal to the product of the two numbers A into B. Okay. So this we can verify. One example we will take. Given that HCF 306657 is equal to 9 and LCM we have to question mark is a find LCM. We have to find the LCM. It is given HCF of two given numbers, that is a 306 and 657 is 9, and we have to find here LCM. So here we will use the property that HCF into LCM is equal to product of given numbers. ठीक है. So HCF is here given 9. LCM we have to find out, and product of the given number 306 into 657. ठीक है. Therefore LCM will be equal to 306 into 657 divided by 9. 9 here 3s are, and 9 4s are, and 934 into 657, and this will give 22338. Okay, so like this we can solve this. So in this lecture we have studied about how to find the prime factors of given two numbers. Then we have studied about the HCF and LCM, how to find it by prime factorization method, that is a fundamental theorem of arithmetic. And about there is a relation between HCF, LCM and given two numbers, that is a HCF into LCM is equal to product of the two numbers, and that example we have taken. Thank you.